Mario once again with MIA Microflight, and this is a CNC router. It's got a long travel on the x-axis. This is about 5 feet in length by 30 inches in depth, and it's got 3 inches of travel on the z-axis. And I designed this machine so that it can cut wood no more than 2 inches in height, because I don't need a machine that can cut anything higher than that. But it is a low profile machine. I guess they call these low riders, and it's because of the gantry is lower to the surface here. So these are the CAD models that I just printed just to have a visual of the machine, how it looks on CAD, and all these parts that were printed for this machine here, 3D printed. Most of these parts are ABS, are the ones that are shown here in black and yellow here. You can see the machine here in its basic form. Perspective view and just a front view of the machine here, and the real machine. So it's pretty close to the CAD model, as it should be. You know, when you do things on CAD and you realize them, with parts, 3D printed parts or CNC machine parts. So one of the things that I did change from the original design is this rail right here. As I mentioned in some other videos, I went with a 2-inch rail, which is very, very, very solid. And I did that so that I wouldn't have to employ two rails here, two 1.5 inch square steel rails. So this 2-inch rail is doing the job quite nicely for the stuff that I'm going to be cutting here. I could employ this machine to cut aluminum. Not steel, but aluminum. I think this machine will cut steel, just after doing some analysis on the rigidity and the way the machine is just designed. I think it will do aluminum just fine. It of course, at lower speeds, you can't push a CNC router that's designed to cut mainly wood to cut metals. So, but I think this machine will do that. And if it does that, even better, because it just extends the functionality of the machine. But this is my machine. You can see it's very low profile, as I said in some other videos. It's very clean design. The motors are hidden. I don't like the motors exposed on any of my machines. I have built, throughout the years, starting back in the late 70s, early 80s, I started looking into building my own CNC machine, and I actually built a CNC machine back in the early 80s. That was just a small footprint machine that had a similar low-profile design, and it was designed to cut basically just fiberglass parts from flat stock, so I didn't require the too high of a Z travel, and so that machine worked out really, really well. I still have that machine, believe it or not. It's actually sitting in my shed, because over the years I started dismantling that machine. That one used a Rotozip Spiracut. You can see that right there. It was the actual router, with the spindle that I used on that particular machine. So that's how I started making my own machine spec, starting in the the early 80s. And so from that point on, I have done some other machines, customized machines, as my work has required that for the, when I started making the micro helicopter upgrades, I needed specific machines to do specific tasks. I bought some, and then I also designed some, to do specific tasks. And so that's how I've been basically that's my background, as far as CNC machine assembly. So this machine is no different than some of the early designs that I did, and so it follows kind of the same architecture, low profile, solid base on the machine. I ended up welding the base. That's what those metal brackets are for. I think I said that in my previous videos. But for anybody that's wondering, so this is a welded steel square tubing steel base on this machine. I just installed this board right here. It's a 5/8 particle board, and this is going to be the actual the base. On top of this, I'm going to have a 1/2 inch spoil board, and then on top of that, I'll be cutting the actual parts. So this is just another update where this machine is at. I'm getting ready to make all the connections to the motors. As you can see, I've been braiding these wires in a. This is a setup according to these motors here. And these are some old motors that I had, back from the day when this company first showed up on the internet. I bought one of their machines, the Fireball 90. I still have that machine. Then I started buying their motors because I really like the motors, and I like I actually like the controller that they had with the Fireball 90. I still have those parts, that machine. And so I actually I had these sheets printed back in the day, but I lost them. I don't think they're lost. I think they're in some folder in my library. But I just recently printed these so that I can have the wiring schematics. And so the way I'm going to be doing this is I'm going to be setting this up or connecting this in a bipolar only parallel setup right here, which gives the higher torque and power here. It does draw quite a bit of amperage here if you connect it as a bipolar only parallel according to these specifications. The amperage per phase is 4.2 amps, but I'm not worried too much about that because the drivers that I'm using on the control board and the controller board, they can handle just fine, that kind of amperage, and even more than that. I think they can handle up to 10 amps. So so this is where I'm at with this machine. It's a very customized design. You won't see a machine like this, industrial or do-it-yourselfer, because it's a very unique, customized machine. Like I said, and just the way I approach things is very different than most of the machines that are out there. 99.9%, I would say, of the machines that are out there, commercial as well as do-it-yourselfers, they have the motors on the outside of the machines, and that to me is very unsightly. And you don't have to put the motors on the outside. You can hide them like I did here underneath these rails here. I am employing these trucks that are made from square tubing and using skateboard ball bearings, and the machine is very fluid. With those types of trucks, which makes for a really nice rail system. If you do this, really you really don't need to be too particular about this. As long as you drill the holes correctly on these square tubings and you get everything aligned right, everything works out pretty nice. And then you tighten the screws just enough to allow this to flow, but also to maintain structural rigidity on the assembly here that's going to hold the router. I'm going to be employing a ported cable router here, the same one that I had, actually the same one that I last used back in 2012. So that gives you an indication of how long it's been since I've done CNC machining on a CNC router. I ended up taking that motor out from the MaxPad 42, which is the blue anodized machine that I show in some other videos. I was actually going to do a facelift on that machine, but then I decided to do this particular machine because I already had the plans for that, and I really wanted a machine that would have the travel, they would have the x-axis travel on the longer rail, and so I decided to just go with my own design here, and it's actually been a lot easier than having to revamp the other machine, because I would have had to kind of piece together things and kind of modify things. So it was a lot easier for me to just I already had these tubes already cut. I already have the frame, and it was just a matter of doing these parts right here, the 3D printed parts. I am going to be changing some of these parts. Once I get this machine going, I'm going to be replacing some of these to aluminum. These brackets will have to be aluminum because right now these are 3D printed. These are just these are PLA. The rest of the parts are ABS. So ABS would also work here, but I think I'm going, because this is not as thick as the other parts, I am going to be machining these in aluminum, replacing this. It'll provide a much better structure here for this Z assembly here. But that's pretty much the way this Z assembly looks. It's a pretty nice looking Z assembly. Like I said, I can't get over how smooth these trucks work, with these types of rails here. And I'm not the first one to do this. There are other people that have employed similar trucks on their machines, but this is a little more customized and refined, in my opinion. I hope I'm not too arrogant in saying that. But I have spent quite a bit of time in trying to refine this so that it looks really nice, and it's not so in your face. So I'm quite happy with the way this machine has turned out. It's turning out, actually. I still have quite a bit of work here to do, and the connections are going to take me a while. I have to get the proper wiring here. I have to order some new cables, because I could use the other cables from the other machine that I took apart, but I think I'm just going to start from scratch. Just get some new fresh cables. I do have to connect the limit switches on this machine, so I have to do that. I have to connect the lead screw for this for the X-axis here, and also the motor and the lead screw for the Z-axis here. So that's it's going to take a little while here, but I just wanted to, like I said, I wanted to make an update and just capture this with the actual CAD drawings that I did before I started making this machine. Mario, once again, stay tuned for more. Thanks for watching.